this is kind of like day 2 of working on this pinball machine, and it's interesting the things you learn. Keep in mind, I've never worked on a pinball machine before. On the other hand, this particular one, the vintage of it is kind of a good vintage for me, because it actually came out in 1984, and a lot of the technology I'm probably more familiar with than some of the newer stuff that I've worked on recently. It's all TTL logic and a lot of relay logic and things like that in there. So there's a latch under here that you can pull down, and once it's been pulled down, you can take this piece off the top here, and once that is off, then you can slide out the glass top, and I've already done that, so there's no glass top in here now. Took that out, set it aside where it couldn't get broken. Once you've got all of that apart, you can actually take this, and there's even a little handhold, and you can just take this and lift this up. And you can lift it, and it's hinged, and then there's a little brace, kind of like a hood on a car, that you can put up to hold it in place. And once you've got that up, then you have access to all of the circuit boards and the relays and coils and actuators that are inside here. And you can also access the transformers and all the fuses down in the bottom. And here's something interesting. I went through, checked all these fuses. They seem to be good. But one thing that was kind of odd was when I connected to the wires at the end here and went and tried to connect to the other end of each of these fuses are all connected together on this end, these three, and these three are connected to the end. And so I'm checking the other side of these fuses, and I'm not getting continuity, or at least not reliably. So what I think may be happening here, one problem with this is that these fuse holders are just really oxidized and are not really making good contact. Some of them are, some of them aren't. That one's not, that one is, that one is, that one is, but that first one, oh, now it is. So it seems fairly intermittent, so I think I'm going to first of all spray those and just make sure that we clean them up. Use my handy little fuse puller. It's some I picked up somewhere along the way many years ago. Got some 600 grit sandpaper, and I don't know if this is the best way to do things, but I just happen to have it here. So I'll just shine up that, and then I'll do the rest. So let's try this again and see if that helped at all. Okay, that looks a lot better. Okay, there's one thing. Now we will try these other ones down here. That one doesn't seem good. The fuse is good, but the connection doesn't seem too good. I'll probably clean up all of these, even though most of them seem okay. Yeah, I think I'll take them out, all of them, and clean them like the other one. Okay, let's try this again just to make sure. It's interesting, as I was doing that, I found that a couple of those fuse holders were a bit loose. They weren't clamping down on the fuses very well. And so I basically pushed them together. The other thing that I found that was interesting was this. We have a capacitor in here. It's a fairly large cap. It's a 6800 microfarad at 25 volts, and it's got two wires that are just hanging loose. And I found another cap that was just rolling around in there of the same, and it looks like that was mounted here and it's been cut off. Now initially I thought, well, maybe that was a replacement cap and they had replaced this cap here at one point, but it doesn't look like it. It looks like they've cut that out of there. Maybe that cap is bad. I should measure that and see if what it's reading. This it's a large cap, so it may take a few seconds. Well, that says basically 9100 microfarads. Now caps, the accuracy of a cap can be wide range, especially in these old caps. That one's in circuit, so I'm not sure. I don't know if that's giving me a good reading in circuit. Yeah, either that one is shorted or else it's reading the, this is a bridge rectifier here. So we could have a problem there, or it just could be that it's seeing the bridge rectifier across there. I may have to disconnect the wire to be sure about that one. So in the documentation that I got with this pinball machine, one of the things that it said that when you're doing service on these things, the first thing you should do, even before you power it up, is to check the resistance of the coils. And there's a lot of coils in here in various solenoids. And the reason why they say that is that they say that if a coil gets switched on and left on, they get warm, they get hot actually, and it breaks down the insulation on the windings in there, and it can short out windings, which can reduce the overall resistance of the coil, and that in turn will burn out the transistors that are driving them. And so they say if you've got a bad coil, you probably should check to make sure whether or not the driver transistors are a problem as well. So in that information, it says that all of these coils should be greater than 2 ohms when you measure them, and you should go through and measure all of them before you start. And typically they're saying they should be around 3.4 ohms, which is pretty low resistance. And so I thought, even though I actually have already powered this up, I thought I'd better backtrack and check these out. So that's what I'm going to do right now. And I'm going to make a diagram to record what the resistances are on these. Now the various ones that I can see, and I'll have to go back to the information to see if I'm missing any. There's a coil here for a actuator, one here, there's one here and one here, one here. There's 3 down here, and there's a couple down at the bottom here. And I think that's all there is on the bottom of here. There may be some others elsewhere, but I think it's all right there. So we're going to measure that. So the resistance of this first one is 3.2 ohms. Just take note of that. Now this one measures 42 ohms. That doesn't seem right because those are very similar coils there, but that is that's high, which you would, according to what I read, it should be low. Double check it with the opposite polarity. Yeah, the same. Okay, now let's try this one here. That one's 6.9. That probably isn't totally out of range. That one is 7 ohms, so those two, maybe a little different coil with slightly different resistance. .9. .1. That's close to out of range, but it might be okay. .8. .5. .222. Interesting. And this one down here. For this one here, I had to disconnect the solenoid on top so they could get at the terminals to measure it, but it came apart quite easily. That one is 223, so that would lead me to believe the first one is probably right. These are made so they can be removed quite easily. So that's all of the coils I can see in there. So one of those looks a bit suspicious. The one that's 42 ohms. That doesn't look right to me because it is similar to the other one and it's much higher. Okay, that still measures 42.2 ohms when the wiring is disconnected from it. Okay, so this one looks right, and this one looks like it may be faulty. That's one thing I do not have a spare of. I'm not sure if I can order one, but I may have to try. Those particular solenoids are the ones for the flippers, actually. So I found some information in some of the documents that came with this pinball machine and on the flippers. And so this schematic that you're seeing right now is just a simplification of what's actually in the circuitry. So you'll see that this flipper is controlled by a couple of contacts from the T and Q relays and a normally open switch, which is the actual flipper button. And this is run off 24 volts. And you'll notice that the 24 volts comes through a fuse, then through those contacts, and the switch goes through the coil, and this goes to ground. And you'll notice also a end of stroke switch that is connected to the middle of the windings of that solenoid. And this proved to be the problem. The actual full resistance of that solenoid coil is 40 ohms, or approximately 40 ohms. But the way this thing works is that they tap off the middle of that solenoid, or not actually in the middle, towards one end, so that initially the resistance of that coil is supposed to be only about 3 ohms. But after you hit the flipper button and it pulls in the flipper, there's a set of contacts that open and then allow the full resistance of the coil to be in series with the 24 volts. And this ensures that if you hold the flipper button closed all the time, it will not overheat that coil and damage it, because there's a lot of current flows when you first push the button, and you want that initial surge of current so that it'll pull that flipper in very quickly. And then once it pulls in, that contact opens and the resistance is increased to 40 ohms, which then decreases the current, and so it doesn't get hot. Otherwise, if you were to hold that button in, the solenoid would get hot and burn out eventually. So that's why I was measuring 40 ohms on one of those flipper coils and about 2 or 3 ohms on the other. It was because that normally closed contact was not making, and it was because it was bent out of shape and had to be rebent back and the contacts cleaned. And once I did that, both of the solenoid coils read around 3 ohms. And if I pulled in the flipper, they would read 40 because that contact would open up. And also, the two contacts that you see on there are from the T relay, which is related to the tilt, and the Q relay, which is the game over. So if you tilt the machine, that T contact will open up and it'll disable the flipper, and the Q contact has to be pulled in order for the game to be on. As soon as the game is over, that contact will open up and it'll shut off the flipper as well. So here's a close-up of the Q relay and the T relay. The Q relay is on top. Sorry about the shaky camera work there. But those two relays can be actually unclipped and taken out and worked on fairly easily. You can see the open contacts on those relays. They were actually badly bent, and the contacts were not engaging when they should. Once I bent them back into shape, things started to work much better on the pinball machine, and it led me to the next step. So I think we're going to wrap up this video at this point, and we'll have a part 3. I didn't originally intend for there to be 3 parts to this, and hopefully I've not gone into too much detail more than you would like, but I know some people like kind of geeking out on some of the more in-depth details. And this one has covered so much ground. The first video was really largely about tracking down problems on the power supply board and fixing a few bad solder joints and just kind of putting it back together a little better. Now this one has focused a little more on the relay contacts and measuring solenoid resistances and so on. The next video is going to deal with several things, especially some of the mechanical aspects of things. We had to replace some rubber bumpers. There was some fixing on the mechanics of the flippers. And then there was also a bit of electronic work, as we had to change at least one transistor and do some other testing. So there's quite a bit to be said about this even now, so I think we'll leave that for part 3. So hopefully you got something out of this and enjoyed it. Be happy to fill in any gaps that I may have missed if you want to put a comment in below. And I'd sure appreciate it if you'd give me a like, and I'm always looking for more subscribers, so please do subscribe. And I think we'll just kind of cap it off at that point, and we will talk to you again on the next one. Thanks for being here. We'll see you the next time.